Hello children. Today I will take a very important topic which is both in class 8 and class 10, and the name of the topic is lenses. Transmissive optical device that focuses or diverges a light beam by means of refraction. In general terms, we can say that lens is a transparent optical device that uses the phenomenon of refraction. Now, what is refraction? Refraction is the bending of light ray as the ray moves from one transparent medium to another. There are many types of lenses available in market, but we will be focusing on two types of lenses. The first one is the concave lens or the diverging lens, and the second type of lens that we will be talking about is called as a convex lens or a converging lens. Now, this is the diagrammatic form of both the lenses. As we can say that the convex lens is thicker at the middle, whereas it is thinner at the sides, whereas a concave lens is thin in the middle and thicker at the edges. Now I would like to talk about the terms related to lenses. Here I am displaying a basic convex lens. Now before I talk about the terms related to lenses, I would like to talk about center of curvature of a mirror. As we all have studied that center of curvature is a center of a sphere of which the mirror is a part of. Now as we see here, this lens has two sections which could be completed in two types of spheres. Hence, we can say that a lens has two centers of curvatures. Here in this diagram, they are marked as C1 and C2, and in general, in lenses, they are called as 2f. So, we have 2f1 and 2f2. In the middle, we can see a point O, which is called as optical center. Now, this is a very special point on the principal axis, which shows a very important property. All the rays which are passing through this point after refraction goes undeviated. As you can see here, I draw a ray diagram, a ray which goes undeviated after refraction. So such a point is called as optical center. Now what is this principal axis? A straight line which is passing through the center of the lens and contains the focus, the center of curvatures and the optical center is called as principal axis. Here I will be talking about the principal focus of convex and concave lens separately. Now when we see the convex lens, we can see that all the rays which are parallel to the principal axis after refraction meet at a special point which is marked as F2. So we can define principal focus of a convex lens as a special point on the principal axis at which all the rays which are parallel and close to the principal axis converge after refraction. And the distance between this optical center and focus is known as the focal length, which is marked by F here. Now when we see the concave lens, we all know that it is a diverging lens. So all the rays which are parallel and close to the principal axis after refraction appear to be diverging from a common point which is called as focus. So from these 2 points, we can define the focus as the point of convergence or divergence through which all the rays of light which are parallel and close to the principal axis appear to converge or diverge after refraction. Before moving to the image formation by the lenses, let us have a look at the rules which we used for image formation. The first rule says that any ray which is parallel and close to the principal axis of the lens after refraction passes through a point focus. Now as we see in the convex lens case, the ray which is parallel and close to the principal axis after refraction passes through the focus. Whereas in the concave lens, the ray which is parallel to the principal axis appears to be diverging from the focus of the concave lens. So I would like to generalize the rule 1, which is any ray which is parallel and close to the principal axis converges or appears to be diverging from the focus of the principal axis of the lens. Let us have a look at rule number 2. Any ray which is passing through the optical center of the lens, which is marked by point C here, goes undeviated or goes in a straight line after refraction. The whole The rule holds true for both convex and concave lens. Let us have a look at rule number 3. First, I'll talk about the convex lens. Any ray which is passing through the focus of the convex lens after refraction becomes parallel to the principal axis. When we talk about the same rule for the concave lens, we can say a ray of light directed towards the focus after refraction goes parallel to the principal axis. In my next video, I will be talking about the image formation by convex and concave lenses.